to the last day to forget. Okay. Questions on this one? All right, so see if you can, in 5 minutes, see if you can do, so I'll give you an easier one. So this one's pretty hard. I want to make sure we saw a hard one, but see if you can do r equals 2 cosine theta. Hold on, make sure I got the right one. Yes, 2 cosine theta plus 2. So sketch the wave in the Cartesian plane. Okay, did you get it?
This is a very friendly graph.
This is very friendly because it never goes negative, right? And it's the period is easy, right? 0 to 2 pi. So you should see that from 0 to pi over 2, it goes from 4 to 2. See my radius tracker there? And then from pi over 2 to pi, it goes from 2 to 0. And then from pi to 3 pi over 2, third quadrant, back out to 2, and then last quadrant from 2 to 4. So you should have gotten from 4 to 2, wrong slider, from 4 to 2, from 2 to 0, and then it's going to bounce back out to 2 at 3 pi over 2, and then from 3 pi over 2 to 2 pi out to 4 again. So it's not a circle, right? It's not a circle. It's got this, it's like it's a piece of fruit or something. Okay, so what is the high point of the graph? So the high point would be what? It would be the highest, what coordinate? It would be the greatest r? No, it's not the greatest r. It's the greatest what? It's the highest point on the graph. Is it the greatest theta? No. It's not the greatest r, it's not the greatest theta. It's the greatest y, right? So if it's the highest point, it's the highest y. And so if we want to maximize y, we need to use the fact that y equals, what does y equal? Always, for all points on this graph. R sine theta. What is r? Nope, it changes, right? What r is equal to? No. Well, yes. All points on this graph, r is 2 cosine theta plus 2, right? That's what our function is. So depending on theta, it's 2 cosine theta plus 2. So we do 2 cosine theta plus 2. Well, before we do that, let's do it generically, right? So if we want to get the maximum y, so let's just say r is our function of theta, no matter what it is. In our case, it's 2 cosine theta plus 2. So if we want to get the maximum y, what do we want? We've got y as a function of theta. We want, I'm going to use calculus to help us find the maximum y. We're interested in, okay? So right here for a change in theta, we want what to happen? The change in y to be 0, right? So we're looking for a little change in theta right around that point. We're looking for where the change in y is 0, so we're going to look at dy d theta. So if I'm going to find dy d theta, what do I have to do to get dy d theta? I got a function of theta, that's our function, r, times sine theta. So if I want to get dy d theta, that means theta But what do I have to do? F theta times sine theta means product rules. Two functions of theta, right? I've got my function of theta, which is our curve, and y is always r sine theta. So I gotta use the product rule. So derivative of the first times the second plus the first times the derivative of the second, which is? So this will always be true. This is always true because I did the generic case, right? I did the generic case of f of theta. So that's always going to be true for dy d theta. Now for our graph, the one we have, what is it? So what is dy d theta for our graph then? What's f prime of theta? So we come to here. So it'll be -2 sine theta, right? Times sine theta plus 2 cosine theta plus 2 times cosine theta. So now we just do the math and see what happens, right? Do the math. So I got -2 sine squared theta plus 2 cosine squared theta plus 2 cosine theta. So close to sine squared plus cosine squared equals 1, right? But no cigar because this is minus, right? It's actually cosine squared minus sine squared. So I can't use the Pythagorean identity to make that 1. So I'm stuck with this here. And I need this to be 0. So let's get rid of the 2 first of all. Because I got a 2 in all 3, so I can, because it's equal to 0, I can divide by 2. So what I really have is like a quadratic of these trig functions. So in order to do that, I need to get them all the same. So I have a cosine squared and a cosine. So let's change that sine squared into cosine. The sine squared into cosines. And then we'll have all cosines. Right? So what does sine squared equal in terms of 1? Yeah, right. So sine squared by that identity is going to be 1 minus cosine squared. So I'm going to change to black before it gets too blue here. All right, so minus 1 minus cosine squared plus cosine squared plus cosine. No, it looked like they almost canceled out, right? But it's actually, we have now positive 2 cosine squared. Because this is going to be negative, negative makes positive, so, and then add another 1, so it's 2 cosine squared plus 1 cosine minus 1. So I have a quadratic of cosine. So just imagine this like 2x squared plus x minus 1. How do you solve those? Yeah, factor if you can, right? And if not, quadratic formula, but we sure don't hope for that, right? But does this factor? We need to multiply to 2 and add to, and then multiply to -1, and then in the middle add to 1. So 2 cosine and cosine. So to get a product of -1, I need -1 and +1. Can I arrange that to get +1 as the middle term? Does that make sense? Just like you would factor, right? So -1 first, +1, or +1 -1? I want this to be, I want to get +2, right? I want to get +2 and -1 here, so it's going to be that. Is that what you're thinking? I need my middle term to be plus cosine. So it's going to be positive 2 minus 1. So when does dy d theta equal 0? When cosine theta is 1/2? Or when cosine theta is -1? So we're saying At these theta values, you change theta just a little bit, you won't get any change in y, because we started with dy d theta equals 0, right? So cosine theta equals a half at theta equals? Yep, pi over 3. Does that look like where we were here? Yeah, it looks like it's right on this radial line here, which we know is pi over 3 right there. It looks like it's hitting it right there. What about negative 1? So cosine is negative 1 when theta equals pi. So does that make sense? We come here in here at pi, does it make sense that we're, yeah, like it's like coming in, so if I just zoom in. When we come in at pi here, it's flattening out, right? So right around pi for a change in theta, y doesn't change. So it's what? Horizontal tangent, right? So then we can get the coordinates of that high point by, we know that our function is this, so we could plug pi over 3 in here. And that will give us our r value. And then if we want x and y, we know x is r cosine theta, and y is r sine theta. Okay, I'm going to talk through some other stuff here. So what if we wanted vertical tangent? We wanted to isolate points where it's the furthest right or the furthest left. We're going to do, listen carefully, don't have time to do it. We're going to do dx d theta. And so we're going to start with x equals r cosine theta, right? X is r cosine theta. So you're going to have the same process for this. Dx d theta, you're going to find using the product rule, but you're going to start with f theta cosine theta, or r cosine theta. And if you want places of vertical tangent, or farthest right, furthest left, you're going to say dx d theta equals 0, and do the same thing. Now what if we just want the Cartesian slope or to the curve? What's the Cartesian slope to the curve? The Cartesian slope. dy dx. How are we going to get dy dx? We've seen it before, right? dy d theta over. So you know how to do dy d theta. Dx d theta is the same way, but you start with r cosine theta, right? If you make those two product rules into a ratio, you get what? You get dy dx as a function of theta, right? So as a function of theta, you're getting the slope of the curve, the Cartesian slope of the curve dy dx. So then you could do something like find the equation of the tangent line, because you have the slope. Right, so if you plug in a theta, then it will isolate a point. This will be a function of the slope. Plug in a theta, you'll get the slope at a particular theta, and you can get the point, and then you're home free.
It's like adding constants to the actual equation of that line.
Yeah.
On the bottom, there's like one more horizontal line for.
Oh yeah, thank you. There's another place where cosine theta equals 1/2, and that's in the fourth quadrant. Thank you. And that's theta equals 5 pi over 3. So we missed that, right? So from 0 to 2 pi, there's actually two places where the cosine is a half, at pi over 3 and 5 pi over 3. And that second one that we overlooked, Vivian saved us, is down here at 5 pi over 3 in the fourth quadrant. Okay, anybody have a question before Cerny has a urgent announcement? Any questions? Yeah, quick.
Quick questions, like to find the equation of that tangent line, I know how to find the slope, but then would you have to find it's like, because obviously it's not through the origin, so it would be like a constant. Like how would you get to this?
So this gives you the slope dy dx,
Yeah.
and then you have the point, like we found this point, right? You could find the point in x and y coordinates, r cosine theta, r sine theta. And then you have your x and y points and your dy dx, and it's just like what you've been doing for equation of the tangent line for the last
Yeah.
4 years. Make sense?
Hi, everyone. This is my last day with you, unless you come to the review. So if you come to the review, I'll see you then. And if not, I cannot find Nikita, Nicholas, and Jared. But hi, I cannot find Nicholas and Nikita, so come up if you want to get your homework. And if not, have a wonderful holiday and a wonderful working week.
Blackboard announcements will have all